Yeah. Hello everyone. Myself Dr. Saloni Goyal, specializing in physics with 2 years of online teaching experience, during which I have taught many students from India as well as from abroad. So presently I am preparing students for grade 6 to 12th for CBSE, IGCSE, ICSE and other boards, ICSE and Foundation Physics too for the classes 8th to 10th. I also take competitive exams coaching like NEET, NSTSC, and Olympiad exam like that. So, if I talk about my qualification, I have done my PhD in physics from NIT Kurukshetra, and before PhD, I have done my MTech from the same institute, and I have completed my BTech in instrumentation engineering from Kurukshetra University. So today I will be going to teach you the topic kinematics. Okay, let's start it. Kinematics. So what do we mean by this word? See, it is made up of two words, kine and matics. Kine means motion and matics means mathematics. It means here we will study about the motion of the object with the help of what? Mathematics, right? So kinematics. Now coming to its introduction part. So there are two terms, rest and motion. Okay, if I ask you what are the two states of any object? The two states of the object are it can be at rest, it can be in motion, right? So how will you define rest? Rest means what? How will you define rest? If a body does not change its position, does not change its position with respect to frame of reference, with respect to frame of reference, as time passes, it is said to be at rest. It is said to be at rest. So what do we mean by this? See, when we will say that body is at rest, if the body does not change its position with respect to frame of reference as time passes. Suppose, let's say I am saying this is one body. Okay. So can I say it is at rest? Yes, it is at rest, or we will say it is stationary, right? Because see, it is not changing its position, right? I will explain this term frame of reference later on. First, I'll explain to you what do you mean by motion. Okay, so it is said to be at rest. Now, if the same body, if it moves and it comes to this position, then we will say this body, it is in motion now. Simple. Okay, now how will you define motion in the terms of physics language? Motion. If a body changes its position with respect to frame of reference, with respect to frame of reference, as time passes, it is said to be in motion. Okay, so if a body changes its position with respect to frame of reference as time passes, it is said to be in motion. Now, what is the meaning of this word frame of reference? Okay, let's see this. Suppose I say there is a person, okay, he is standing here on the platform. For example, he is the person, let's say this person name is A, he is standing on the platform and there is a tree in front of him. So tell me, is this tree, it is at rest or in motion? It is at rest, right? See, it is not changing its position, it is stationary, it is simply at rest. Can I say this tree, it is at rest Here? Yes. Okay, now if I say the same person A, now he is here. Okay, he is sitting inside a car. Let's say this is a car which is moving on the road, and this car, it is crossing this tree. Now the same person A, he is sitting inside this moving car, and this car is crossing the tree. Okay, so when he is crossing this tree, now he is looking over this tree, okay, through this window. Now this tree will be at rest or in motion. Think about it. This tree will be in motion, right? Now, when the same person, now he has changed its position, he is now sitting inside this moving car, and this car is crossing this tree, and he's looking over the tree from his window. Now he will see that this tree, it is moving in backward direction. He is moving in forward direction, let's say with the speed v, and the car and the tree will move in the backward direction. So what does it conclude? Earlier, the person was standing on the platform. So, for this person, this tree was at rest. But now, the same person, when he is sitting inside the moving car and he is crossing this tree and he is looking on the same tree from this window, now this tree will be in motion for him in the opposite direction, right? See, in both of the cases, this person is right. Can I say? This person is right here and this person is right in this situation also. So what is this? This is the meaning of frame of reference. See, here the reference frame, this is my reference frame. This is the frame here which is at rest, frame at rest. But here the reference frame, this is my reference frame which is in motion. Can I say this is frame in motion? See, that's why we always define the state of the object with respect to frame. See, I wrote here the definition. If the body does not change its position with respect to frame of reference, see, with respect to this frame, this body is not changing its position. That's why it is said to be at rest. But in the other situation, the person is standing in the moving frame. So with respect to this frame, this tree will be in motion, right? So that is why we always define rest and motion with respect to frame of reference. Is it clear? Okay, let's take one more example to clarify this thing more. Okay, let's say this is a car here and there are two persons sitting inside the car. Let's name them. One is A and another is B. And third person, he is standing outside the car. Okay, he is simply standing on the floor and this car, it is moving in this direction. Let's say with some speed V. Okay. So now, if I ask A whether B is moving or not, what would be his answer? Yes, whether B is moving or not. His answer will be no, B is not moving. B is at rest, right? But now if I ask the same question with C, whether B is moving or not, what would be his answer? Yes, B is in motion for C. So C, A is also right, C is also right. What is the difference here? The difference is about the frame. See, when I asked A that B is moving or not, he said B is not moving. It is at rest because both of them are sitting inside this moving car. So here the frame is this, right? So this is the frame in motion. But when I ask the same question with C, so with respect to this frame, this B, it is in motion. So this is what? This is my frame at rest. So with respect to this frame, this person B, it is in motion. See, both A and C are correct. We can say both A and C are correct at their own places, right? Nobody is wrong. In the first case also, this A was right. Earlier case and this case. Here A and C both are right at their own places. See, the only difference is frame. That's why we always define the state of the object, whether it is at rest or it is in motion, always with respect to some frame. With respect to that only we can say whether it is at rest or it is in motion. I hope that is clear to you. And so can I conclude this here that rest and motion, are relative terms. Are relative terms. There is no term like absolute rest or absolute motion. Is it clear, everyone? Absolute motion. Fine. So there is no absolute rest. We cannot say this object, it is at rest. Okay, maybe for some other reference, it could be in motion. That's why they are relative terms. There is no term like absolute rest or absolute motion. Okay. Now we divide motion into three types. Okay. So we divide motion into three types. First is motion in one dimension. Motion in one dimension. Second is motion in two dimension. And third is motion in three dimension. Okay. So in this chapter, actually this chapter kinematics, firstly we will discuss what motion in a straight line. Motion in a straight line. And it deals with what? It deals with motion in one dimension. Motion in one dimension. So for now, I will only tell you about motion in one dimension. So what is the meaning of motion in one dimension? Yes. See, whenever the body, it moves in a straight line, we say the motion is what type of motion? One dimension. Whenever the body, when body moves in a straight line, it is said to be moving in one dimension. Let's talk about it, some examples. Okay, let's say if I say the car is moving on a road. Okay, so there is a car and it is moving on a road straight. Okay, so can I say its motion is one dimension motion? Yes, because it is moving in a straight line. Any example, any other example? The train moving on a straight track. That could be also the example. Or what else could be the example? Okay, let's say if you are having a ball, okay, this is a boy over here and he is having this ball and he throw this ball in the upward direction. How will it go? It will go straight like this, right? And after reaching here, it will come down, right? So when it is going in straight path, can I say the motion of the ball is a straight, if it is moving in a straight path, so the motion will be which type of motion? One dimension motion, right? When it is coming down, then also it is one dimension motion. Okay, if you throw the ball on the floor like this, then also it is one dimension motion. Okay, so whenever any object, it moves in a straight line, we say it is one dimension motion. Okay, so this type of motion is also called as what? Rectilinear type of motion. Rectilinear type of motion. See, as its name is saying, rectilinear. See, linear means when something it is in a straight path, right? Rectilinear type of motion. That's why 1D motion is also called as what? Rectilinear type of motion. I'm not going into two dimension and three dimension. I'm just telling you here two dimension we can say that is motion in a plane. That is the next chapter. Okay, this is motion in a straight line. So it deals with only one dimension motion. The next chapter is motion in a plane, that will deal with motion in a two dimension. And three dimension means we will say motion in a space. Fine. So now types of physical quantities. Physical quantities. See, there are two types of physical quantities. Scalar physical quantities and second one is vector physical quantities. Okay. Now, what is the meaning of scalar physical quantity and what is the meaning of vector physical quantity? See, scalar physical quantities, first of all, what is the meaning of a physical quantity? Physical quantity is any quantity which you can measure. For example, if I talk about this pen, okay, and I want to measure its length. So, length will be my physical quantity because see, I can measure its length, right? How? By using a scale, right? By using a scale, I can measure its length. So length will be my physical quantity. Same way, I can measure like this is my phone. I want to measure its mass. So I can measure its mass. So that will be the mass will be my physical quantity. So any quantity which you can measure using some instrument that will be called as what? Physical quantities. Okay. We can divide physical quantity into two types, scalar and vector. So scalar physical quantities are those quantities which only have magnitude, which only have magnitude. Okay. And vector physical quantities are those quantities which have magnitude plus direction. Now, what is the meaning of magnitude? Simple. See, if I talk about any measurement, let's say talk about this pen. Okay. If I measure its length, let's say it is coming 10 centimeter. I am measuring this length using a scale and let's say it is coming 10 centimeter. Okay. So what is this? This is the measurement here. This is the measurement. What is this measurement? This is the length of the pen I measured. Length of pen. This is just an example I am taking to make it clarify what is the meaning of magnitude. So here, any measurement, basically it consists of two parts. One is magnitude and another one is its unit. Okay. Can you see here two things are present? One is this number and another one is this unit, right? So this number is representing what? That is my magnitude. And this is what? This is my unit. So magnitude is nothing but that is the numerical value. Okay, in any measurement, if you take the mass, if you take time, if you calculate the time, if you take the weight, obviously there will be one unit and there will be one number. So that number will be your magnitude. Am I clear? So this is my magnitude. So magnitude is nothing but we can say it's a numerical value. Right? It's a numerical value. So scalar physical quantities, they only talk about the magnitude. Magnitude along with the unit. Unit will be always there, right? But in the vector physical quantity, it tells you about the direction also, right? So this is magnitude, we can say magnitude means numerical value and this is the unit. So this is my what? Measurement, right? So let's talk about the example of some scalar physical quantity and vector physical quantity. Let's talk about distance. If I say distance, if I say speed, okay, or mass, these all are what? Scalar physical quantity. Okay, they don't include direction. If I talk about distance, I will say 10 kilometer. I won't say direction with it. If I talk about speed, for example, I let's say 10 meter per second. If I take mass, let's say 50 kilogram. So see, they are only containing the magnitude along with the unit, right? They are not telling you the direction. But if I talk about the vector physical quantity, the examples are displacement, velocity, force, okay, and momentum, many more, okay, etc. So see, they will contain the direction also. What do we mean by this? Like if I talk about displacement, see displacement and distance. There is an entire separate topic over this that what is the exactly difference between distance and displacement because we generally confuse between these two terms. They look very similar, but there is a difference. The major difference is that only the distance is a scalar physical quantity and displacement is a vector physical quantity. It means it is having magnitude. It means if I am saying 10 kilometer, this is my what? Magnitude, right? Along with this unit, right? What about this direction? It means if I say there is an object and if it is moving in this direction and it is moving, it is covering, let's say 10-kilometer distance. So how will you write its displacement? The displacement will be how much? See, if I talk about distance first, like as we know, distance that does not include direction. So how will you write distance in this case? Distance will be equal to what? 10 kilometer, right? Simple, without only magnitude, no direction, right? This is my magnitude. But what about displacement? Displacement, how will you write? You will write the magnitude along with the direction. So what is the direction here? See, the direction, you can see it is going in right direction. Let's say, we can say, if I talk about the direction, this is what? East, this is north, this is south, and this is west. So let's see. See, it is going in which direction? East direction. So you have to specify here 10 kilometer in east direction. Okay, so this is my displacement over here. This is distance, this is displacement. This is the major difference. We say there is a only magnitude, but there is magnitude plus direction. So I hope that is clear to you all. So, okay, thank you very much. I am stopping here today. Okay, thank you all.